All right, in 8.2, you were graphing some figures and looking at them in terms of their transformations, which was a review of something from first semester, where you're translating, reflecting, rotating, and then also something new that we're talking about, dilation, and how we can use that to help us show that figures are similar. So the focus of this lesson, again, was how do we show similarity or prove that things are similar or figures are similar. One way is to show that there is transformations you can do that map one figure onto another. If you can reflect, rotate, and translate, which is really just moving it around, and then dilate it, which is making it bigger or smaller, one figure onto another, then those figures are similar. Because in each of those transformations, you're not changing the shape. For dilation, you're just changing the size, but you're keeping things proportional. If you do any transformations and the two figures can be put on top of each other and they look the same, then those are similar figures. Because you're making them into congruent figures by doing those transformations, but originally they were just similar figures. The other way, and probably is the way that we'll most often do it, is we'll look at the sides and the angles of the figures. And if we can show that each set of corresponding sides is proportional, meaning they have the same ratio, that scale factor. So if like the side length is 2 here and it's 6 there, and that's a scale factor of 3. If we can show that scale factor of 3 is true for all of the sides, and all of the angles of the figures are congruent between the corresponding angles, then we can say that the figures are similar. If we can show that for all the sides proportional and all the angles are congruent. So let's look at a few examples in the Check Your Understanding. Again, the idea is that you hopefully have done the Check Your Understanding prior to watching this video. If you haven't, pause it, give those problems a chance to work through them, because that'll be more understandable. It's better for your brain to process it first and then to watch this, even if you aren't totally sure what you're doing. So let's look at a few of these. Number 1, it says, what value of x would prove that these figures are similar? So in order for them to be similar, the sides have to be proportional and the angles have to be congruent. So if we just look at the angles first, we can see that this angle is congruent to that one, this one's congruent to that one, this one's congruent to that one. And if all three of those are congruent to all of those, then we know that these two angles would have to be congruent as well. So we're good on the angles, no worries there. But then we need to look at the sides, and are the sides proportional? So to determine if they're all proportional, we would need to look at the scale factor between them. So from 90 to 10, 90 divided by 9 is 10, 36 divided by 9 is 4, and 126 divided by 9 is 14. So each of them, there's a scale factor of 9 there, or 1/9, you could say. And so what number of x, okay, so there's some number x that when you divide it by 9, it should equal 4. And so what number is going to equal that when we divide by 9 is 4? That's going to be 36. Sorry, not 4. I did this in the last video too. X and 7. Okay, 7. So what number when I divide by 9 is going to give me 7? Because those are the corresponding sides. And so x is equal to 63, where I take the number, divide by 9, and 63 divided by 9 is going to be 7. So if they all have that scale factor divided by 9, then we know this would have a length of 63, so that it is proportional to the 7 side over here. Okay, so x has to be 63 in order for these to be similar figures, because that proportion has to be the same for all of them. All right, let's look at number 2. Is triangle DOG similar, and that's what this symbol is right here, similar, to triangle CAT? Explain why or why not. So if they're going to be similar, then there needs to be proportional sides. Now we're not necessarily looking at the angles, right? You can see that we don't really know much about the angles, so let's just focus on the sides and see if we can determine if they are going to be similar. How do we do that though? Is they need to have a proportional side and similar, or a common ratio between the sides. So if we look at the common sides, 10 and 14, we can find the ratio. 10 divided by 14 reduces to a fraction of 5/7. If you don't want to work in fractions, you can work in the decimal. You just got to be careful sometimes to make sure you're looking at the decimal correctly. Like this one comes out to 0.7143, and so on and so on. Some numbers after that. But if I round to the 3, that's what I get. So all of the other sides need to have that same ratio. So let's look at the next one, 9 and 12. Okay, 9 divided by 12, that as a fraction reduces to 3/4. Well, right off the bat, I can see that those two don't have the same ratio, 5/7 and 3/4. So no, these are not similar because they don't have the same ratio or the same scale factor. Now the thing is, you got to be careful, is like 7.5 here and 10, that actually does reduce to 3/4, and so you would see that two of the sides have the same ratio, but because not all of them do, we can't say that these are similar. Okay, let's look at the last one. Last one is a little trickier. This is one as we're using the transformations to justify if these figures are similar or not. So obviously they look the same, but can we use transformations to actually show that they are? So there's multiple ways to do this, but you kind of want to think about what transformation is going to make these look the exact same. Well, if I start with the smaller one, it's facing up, but this one's facing down. So what I can do is a reflection. Let's see if I can draw this. I can do this reflection to make it face down now. Okay, and so I did first a reflection down, okay, and then I need to move this over here. So if I just focus on this corner right here, I can try to see if I can match them up. So here, to go from here to here, I go up 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So I would translate up 4 and right 8. Some of this looking familiar to what we did last semester. And so then I create the figure right here. But obviously the second one is much larger. So how do I make these the exact same? Well, that's where a dilation comes in. And so if I look at this, if I kind of look at the lengths of these sides, I can determine that by how much I go over and up. So this goes over 1, up 3. So let's see how much the larger one does, though. So from the larger side, I go over 1, 2, 3, and up 9. So this one goes over 3, down 9. Well, if you look at, there's if I take 1 times 3, I get 3, and if I take 3 times 9, or 3 times 3, I get 9. So if I multiply the smaller one times 3, then I get the larger one. And so what that means is I can dilate by factor of 3, and then that would make this the larger side. Okay, if I just multiply everything by 3, then it would create this larger figure here. So doing these 3 transformations, I can create this smaller one and turn it into this one. So that proves that these two are similar. Okay, so yes, by transformations above. So again, that's kind of a trickier way. We won't do that way as much, but it's again just kind of showing you that's how I would use those ideas of translations or reflections, translations, dilations, rotations to show that these two figures are similar. So again, similarity means they have proportional sides and all the angles are congruent. and transformations are a way that we can show that that's true. We'll most often look at it in terms of proportional sides and congruent angles.